So this this was the fundamental equation we have chosen. That is h of s equal to summation k runs from 1 to n, numerator ak, denominator s plus ak. What is this s plus ak? It is nothing but a pole, and numerator it is a gain, and n stands for order. And we need to obtain the inverse Laplace transform of this, by which we could able to get this equation h of t, and later on this equation is going to be sampled to obtain h of n. That is h of n is equal to, so replacing t by nt. So once again we obtain the h of n's set transform. So this is how we put this particular h of n by uh, applying the z transform basic definition. So later on, by interchanging the sums, so this derivation we have done with in the last class. So now we could obtain h of h of z equation, right? So by replacing, so we first interchange these two summations, as we have a direct formula from the of summation ranging from n equal to 0 to infinity. So in the way we apply summation 0 to infinity a power n, that particular formula we will apply here. So once again this is the h of z equation that what we got, right? Now we are supposed to map this onto the s plane to z plane. So in the s plane, so this basic equation was h of s equal to ak divided by 1 plus AK, right? So AK is nothing but a pole. We thought, we understood that that is the point where the pole lies, so that we call it as a SP. And here Z is equal to e to the power of SP into T. So that is how we map from Z plane to S plane. So we know that S is equal to J omega, right? Is consisting of the frequency component basically. So S is nothing but j omega. So similarly, we replace in the Z transform, we replace this by j into omega t. So now what is this mod of z equal to 1? Why it is not any other value? Why it is 1? So here I just write this for your convenience. Okay. From basic definition, h of s equation was summation k runs from 1 to n, and ak divided by s plus ak. So this is the pole, that is sp, and here this is the pole, right? Is it not? So here, if in the s plane, s is equal to sp, this is in s plane, and in a z plane, so if you observe this, this is e to the power of minus akt. So this is what equal to s z. Now s is equal to, in s planes, if you go this, if you go here, so I can write this as e to the power of minus ak, sp equal to e to the minus sorry minus ak. So now here I just replace this by sp. This particular value is going to be replaced by s into t, right? Okay. Now what is this sp? Sp is nothing but a pole. So where, how it is going to be represented as j omega, right? In s plane it is nothing but a, s is nothing but a j omega. We substitute or we replace s by j omega. Similarly, coming to this, because I need frequency component here basically, So where is my frequency component present? It is present in this, right? So again, I replace e to the power of j omega t. Now observe carefully. So we say that mod of z is equal to 1. So which means that, so why this is mod of z is equal to 1? That is very important point here. So e to the power of j, so I can write this omega as 2 pi f into t, right? So either I can write this f equal to 1 by t or t equal to 1 by f. So finally f and t get cancels. Is it not? So what we left with? 2 pi. So what is 2 pi? Cos of 2 pi plus j sine of 2 pi. So obviously j sine 2 pi goes to 0. So we left with only cos function. So that is equal to 1. Hence, hence, if for this the mod of z is equal to or e to the power of j omega 2 is nothing but the value is equal to 1. So this is the frequency axis mapping, which means that what is this 1 indicates, which means that the entire frequency component of S plane, so which is omega. What is omega? Omega is nothing but a frequency component. The entire frequency component of omega will lie within the value 1. What is this 1 represents? What is this e to the power of j theta represents? I'll just take one blank slide here to explain. So with one blank slide, I would like to explain this why, what is the meaning of this e to the power of j theta equal to 1. So look at this. We know that from the z transfer or basic mathematics that we z is equal to e to the power of j theta is the basic definition what we have. How do we write this? So this is cos theta plus j sin theta, or when I map it onto the circle, so it is usually we call it as rj theta, right? So where r is the radius. So how do we represent this z? So this is z with imaginary the real values and z of imaginary values. Fine. So this is the distance of z. So this is how we take the value of z. So it will be at certain distance from the point of origin. So making a suitable angle of omega or theta. In this case, theta. So this value, so this is nothing but which is going to represent my the entire frequencies that lie on my z plane. So here if you observe uh, z is equal to 1, which means that the entire frequency omega, the angle, so here it is z is equal to e to the power of j omega t, and since if I substitute, this is 2 pi f into 1 by f, so this will going to give me 1. So this means the value of the value of I take a mod of value. So this is mod of value, which means that for both the value for plus and minus values, the value lie within the unit circle. That is what the meaning of I need to transfer the entire frequency component from analog to digital. So that will going to lie within this particular range. So that is what the meaning of this z equal to e to the power of j omega t, and that the value of mod z equal to 1, which means the radius with the radius equal to 1, the entire component of z or entire frequency values of z will lie within the unit circle. So this is very important point here. So again, moving further, so we represent this particular frequency as digital frequency. In analog, this was represented by omega. This is an analog frequency, and here we represent this as omega t. Okay, so what is this omega t? This is nothing but a digital frequency. So since the range of digital frequency is from minus pi to plus pi, which is either you can go from 0 to 2 pi or minus pi to plus pi. So here the fact that the value this particular digital frequencies, so this is the relationship between, so relationship between your analog frequency, that is omega. I think I need to make one point very clear here. There is a the the terminology, or what we say, that representation of digital and analog is quite different when you're the way we used to take in signals and systems, because in signals and systems we represented this as an analog and this as a digital, but here with respect to textbook convention, it is quite reverse. Okay, so this is digital signal, digital frequency, and this is analog frequency here. Okay, so relationship between analog frequency and digital frequency omega. Okay, this point you need to understand. Now the entire digital frequency will going to lie from minus pi to plus pi. Reason is, see, entire, if you take this entire circle, so I need to put all the time you should ensure that the digital signal or digital frequency, the range of digital frequency is going to be indicated by which transform, z transform. So if you observe, so this should be from minus pi to pi. So which is nothing but a one complete cycle, I call it as, right. So from minus pi to plus pi. So similarly, it lies for the next half of the cycle, right. So now what we do is this. Hold on. Okay, now the digital signal that is moving from minus pi to pi. So that is digital signal or a digital frequency. I need to map it onto the analog frequency. So what is this analog frequency? This is omega t. So right, omega t. And if write this, the range of analog frequency, the range of analog frequency will be from, the range of analog frequency. I take it t below here. So for left hand side or for right hand side as well. So this will be moving from minus pi by t to plus pi by t. I hope you got this point. See, I am trying to map my entire frequency within this range. Which frequency it is? The range of my analog digital frequency. But from where from where I'm trying to come? So I'm trying from my analog component, right. What is that analog component? This is my analog component, where I need to map this frequency from analog to digital here. Okay, so which is nothing but I need to map my omega values. Now what will be the omega value? It is not, I need only omega, not omega t. So I'll take this here, that's it. Okay, so this is minus pi by t to plus pi by t, is supposed to be mapped onto the frequency on z transform. So if you observe here, so not, so it is not from minus infinity to plus infinity. So it is from minus omega by t to plus omega by t. Okay, so poles mapping here. So just look at this. I will be mapping the verifying the poles. So this probably you understand this in a much easier way. What happens when s by putting s equal to 0, and how to verify this? Let me take up this with one blank slide, and let me explain it here. You will understand the concept very clearly, guys. Please uh, have a patience and just observe this, because you need to even in the examination, when problems are asked, you must able to map this frequency from z s plane to z plane. This indicates mapping of poles of s plane on z plane. Okay. We know that how do we represent s? S is nothing but sigma plus or minus j omega. So this is the basic definition. Now if I move to its equivalent value in z, z is equal to what? What is the definition of z transform? So it is nothing but e to the power of s into t, right? So this is something like e to the power of sigma plus or minus j omega t, right? So this is sp, or you can take s or sp, whatever it is. Just to understand purpose, this is, you need to understand that that is a pole. So e to the power of, so this is uh, I'm sorry, this is minus sigma. It is also minus sigma. So minus sigma t into e to the power of j omega t. Now, one of the point is very clear. My signal Z, the whatever the frequency that I transform from S plane to Z plane, so will it converge or diverge? One of the very important point here, definitely because of this negativity, so the signal used to get convergent, and so that my system would have been in a stable condition. Now this z is getting multiplied with e to the power of minus sigma into t for all the t values, right? For all the t values, the signal, as the time increases, this z value, definitely it is a exponentially decreasing, hence at one particular point it has to come to 0, so that it is going to be a convergent. So once it is going to be a convergent, so signal or a system, z is nothing but a system, the system will be of type a stable system, so no doubt at all. So the system is going to be a stable system. Now the point is, since, so look at this, the mod of z is less than, so since it is equal to mod of z, it is equal to minus sigma t, so therefore it has to come less than 1. So we can conclude that s plane is on LHS side. All the stable values, when it mapped out to the unit circle, or when it mapped out to the z, so that will come under the unit circle. So that is one of the important point that what we try to explain here. So another important point here is, I told you that the frequency range, the signal range is moving from, I need to map this signal from minus pi to plus pi. This is a digital frequency from what? From analog frequency, that is omega t, so from minus pi to plus pi. So which means that I'm not able to map a minus infinity to plus infinity signal very precise frequency that I can able to map it onto the z transform. So that, how do I do it? here. So one is, uh, look at this. This is my S plane. Okay, this is my S plane. Okay, I'll just take this here. I'll draw this. Okay, so this is my S plane. Let me draw the Z plane here. This is Z plane. We know that the entire frequency component will going to be within the unit circle. So but I need to check it here. That's what we are trying here. So this is z equal to 1. So z of real values, z of imaginary values, and this is 1 and this is minus 1, and here it is 0. Now this is j plane, j axis, and real axis of s plane. Now the entire frequency is going to be mapping on. So omega is equal to uh, pi by t, and this is minus omega, that is equal to pi by t, minus pi by t. Okay, minus pi by t to plus pi by t, I'm trying to map. So initially, so this is how s is equal to, this is how my values are going to be represented, any value, any stable values, right? So minus sigma plus or minus j omega, all the poles will be represented in this form. So entire poles are going to be lie on my left hand side of the plane. So it is not getting mapped from minus infinity to plus infinity. That is one important point we should note. Now, how do you map this? S is equal to what? S is equal to j omega, but z is equal to e to the power of j omega, e to the power of j omega t. Okay. Now I need to represent on z plane. I need to represent one of the frequency component, that is at pi by t, where it occurs. Let me take this pi by t. So what happens here? T and t get cancels. See, I am trying to map this frequency on z plane. So hence I am replacing this omega by pi by t value, because that is that is the range of my frequency actually. I need to put these range. So this is maximum value in the positive direction, this is negative, the in the negative direction the maximum value. So all my frequency lie within this particular range, right? So once I say that, so this is my end point. Okay, this is my end point. Okay, whatever the signal that appears, so that signal will be going to be present here. Whatever the frequency that are going to be present, so that frequency will going to present within this range. So hence I take the maximum value and I see that. Okay, so this is e to the power of j pi. What is e to the power of j pi? What is the value of e to the power of j pi? What's the value j pi? It is nothing but minus 1, right? What is the value of z equal to, now what is the another value? So e to the power of j minus pi by t. So what is this value? Again it is also minus 1 itself, right? So because this is also cos pi plus j sin pi. Okay, this will give me cos pi minus j sin pi. Okay, so this is 0, this is also 0. Here, here this is cos j theta, here cos minus j theta, that's it. Pi with here j pi, what is the value of cos pi? So this is minus 1, this is minus 1. So this frequency, the maximum frequency, will appear here. Let me change the ink color. So this is the first value that appears. So from here, where do I map this? So this is going to be z equal to minus 1. So this frequency is mapped at this point. So that is what z equal to minus 1 for omega equal to pi by t. What about the negative pi by t? So that is also mapping on to the z equal to minus 1 point itself. Okay. What is the minimum value? The other value. So let me assume that where s equal to 0, this is 0, right? 0 comma 0. So where I could able to put here. So once again, let us calculate. So that is z is equal to e to the power of j 0, right? Because omega is 0 here. Omega, the frequency value at this point is 0. So this is nothing but 1, is it not? E to the power of 0, which means that when omega becomes 0, okay, this value is going to be mapped. So this value is going to be mapped on z equal to 1. So this is where it mapped. So which means that entire frequency R, the maximum frequency in the upper positive direction and lower in the negative direction, this is the another maximum value. So all the values will going to be mapped at minus 1, and when at s equal to 0, the value of frequency that comes to be z equal to 1, and that's where all the frequency component of my s plane, all the frequency component of my s plane are going to be mapped onto the z plane within unit circle, that is within from minus 1 to plus 1 range. Hence, whatever you have designed, the equation that what we derived for h of z is completely stable system. So this is one of the conclusion that we draw here. Is this clear? Is this clear? So this is the point is any pole on left hand side of the S plane is represented as minus sigma plus or minus j omega is going to be mapped out to the z plane where z value will be ranging from minus 1 to plus 1, which means that all the frequencies ranging from pi by t to minus pi by t are well within fitted within the unit circle. So this is the important concept that we are supposed to understand here. So this is the way we try to represent here. So this is the mapping of impulse invariance method from a z plane to this. So this is where my frequency component are going to be mapped, and from S plane to Z plane. Is this clear, guys? Any doubts here? Any doubts? Write it. Please copy the same. So these transforms will help me to explain you while solving the examples. So now I'll just say some of the standard Z transforms. uh, Write it down. Some standard Z transform that we directly use in solving the problems. So one is a to the power of u of n. So going this Z transform is, so all these you have studied in your signal science systems. So I don't take much time in explaining or in repeating the same here. So I have a standard formulas. I just take this. So this is one formula, a very basic and fundamental. So n into a to the power of n into u of n. So what is the Z transform of this? So this is a times Z inverse divided by 1 minus a times Z inverse whole square. So this is where the ROC, what we call this as region of convergence. So point is very important, convergence, because unless it is not a convergent, the system is not going to be a stable system. Okay. So another important Z transform of omega naught n, cos of omega naught n u of n. So it is all right-handed sequences because we have u of n. So if it is u of minus n, then it is going to be a left-handed sequences, left-sided sequences. So for this, what is the standard definition? 1 minus cos omega naught z inverse, okay, divided by 1 minus 2 times cos of omega naught z inverse plus z to the power of minus 2. So for this, the region of convergence to be mod of z is greater than to 1. Similarly, a to the power of n cos omega naught n u of n. How do we write this? So this equivalent z transform is 1 minus a into cos of omega naught z inverse divided by, the reason why I am trying to write this, I would have show you directly with this PPT. So unless I don't write, you also don't copy it down. So I want you guys to copy this. Don't sit idly. I hope you all are copying this equations. So this will help you in solving the examples. Directly I'll take, I don't go with any other method. There are two methods to solve this. So this is faster method for me to solve the examples. Okay. So this is one important point. Shall I go for the next page or should I wait? I hope you all have copied down this equations. So note down some inverse Laplace transforms. The standard inverse Laplace transforms that we will be using most frequently. So first one is s minus a divided by s minus a whole square plus b square. So this is the Laplace value, and if I take inverse Laplace of this, so this will be e to the power of a times t cos of at. Sorry, it is cos of bt, not at. B divided by s minus a whole square plus b square. So the inverse Laplace of this is e to the power of at as usual sin bt 1 divided by s minus a to the power of n. The inverse Laplace transform is e to the power of at t to the power of n minus 1 divided by n minus 1 factor. The problem here is I have a transfer function which is in a Laplace transform form. I need to convert this to h of z. Converting h of s to h of z is nothing but conversion of analog filter to digital filter. Now how do you perform this? As I told you, the first step is to going for taking the inverse Laplace transform and obtain h of t. That's it. Very first step. So if you observe this, this is in the form of one of our Laplace transforms like s plus a, s minus a divided by s minus a the whole square plus b square, right? Now accordingly you can manipulate so this to the current scenario. How do you do it? So here it is. In this case I can write my equation as h of s is equal to s minus of minus a divided by s minus of minus a whole square. So now this is in my standard Laplace transforms, right? So I have a standard Laplace transform here. So where for the from the table of Laplace transform, so I have s minus a divided by s minus a the whole square plus b square. So here in this case I used to write like e to the power of at into cos bt, right? So how do you write here in this case? I need inverse Laplace transform. So therefore h of t is equal to inverse Laplace of h of s. So this inverse Laplace, that is inverse Laplace of s minus of minus a divided by s minus of minus a the whole square minus a the whole square plus b square. So of this I can write it as e to the power of a is going to be replaced with minus a, that's it, e to the power of minus at into cos of bt. Now I got my inverse Laplace transform here. So what is to be done next? I need to sample this for t equal to nt. That's it. So therefore h of n is equal to e to the power of minus a nt, replacing t with nt, cos of b, replacing t with nt. So you got h of n. Okay, now what is to be done? Very straight and easy method. So h of n is to be transferred to z transform, that is apply zt to get h of z. So we know that the z transfer formula, h of z is equal to, I directly write the equation here where n runs from minus infinity to plus infinity, h of n. What is h of n? Cos of b, cos b nt into e to the power of minus a nt z to the power of minus n. So this is a standard. This is the definition. In the within this, I apply the value. So next, sorry, this is not from minus infinity. The cos, the z transform starts with 0. So n equal to 0 to infinity. Cos of b times nt. I keep it as it is. So this is going to be rewritten as e to the power of minus a t z to the power of minus 1 whole to the power of n, right, whole to the power of n. So uh, this is we have a standard z transform. If you go back to the table, I'll just show you the standard z transform here. So here it is a to the power of n into cos of omega naught n into u of n. So this is a standard z transform I have. And look at the problem. Look at the problem. Now this is also in the same fashion. A power n into cos of bn. So this is I take it b here also. I take it b also here also. Okay. Now look at this. I can write this as b power n cos of an. Okay. So this is equal to, what is the standard z transform that we have? 1 minus b into cos a into z inverse divided by 1 minus 2 times cos of a, cos of a into b times z inverse plus the denominator itself b into b square z to the power of minus 2. So this is the standard formula that I can able to apply here. So the same formula I am taking from the standard z transforms. Okay, the same formula I am taking it from standard z transform. Now once again, how do you apply here? H of z is equal to the entire thing. So this is the standard value and this is here in this form. I just replace according to my suitably according to my problem, e to the power of, so here b, what is b? B is nothing but e to the power of minus 80 z cos of, cos of bt into z inverse divided by 1 minus 2 times e to the power of, so I take this B here. The B, this B value. What is this B? B is nothing but in our case it is e to the power of minus 80. Okay. Z inverse. I just if you have this confusion, I'll make it separate. N. Ah, now you can easily understand. Okay. E to the power of minus 80 cos of bt z inverse plus e to the power of minus 2 times 80 because b square means if you apply e to the power of minus 80 whole square, so this becomes e to the power of minus 280 into z to the power of minus 2. So this is the standard value, that conversion of uh, h of z, h of s to h of z directly. So I have a other means of way of solving this. Since we learnt Laplace inverse Laplace transform, and this is how we are supposed to take the steps in order to solve using impulse invariance method. In the examination, we will ask you to solve from particular method itself. Okay, solving from solving for z transform by impulse invariance method. So the point is very simple. ಮ್ಯಾಥಮೆಟಿಕ್ಸಲ್ಲಿ ನೋಡಿದ್ರೆ ಇದು ಲ್ಯಾಪ್ಲಾಸ್ ಟ್ರಾನ್ಸ್ಫಾರ್ಮ್ನ ಝೆಡ್ ಟ್ರಾನ್ಸ್ಫಾರ್ಮ್ಗೆ ಕನ್ವರ್ಟ್ ಮಾಡ್ರಿ ಅಂತ ಹೇಳ್ದಂಗೆ ಅಷ್ಟೆ. ಬಟ್ ಇನ್ ಸಿಗ್ನಲ್ ಪ್ರೊಸೆಸಿಂಗ್ ಅಪ್ಲಿಕೇಶನಲ್ಲಿ ನಾವು ಯಾವ ಥರ ತಗೊತೀವಿ ಅಂದರೆ, ಒಂದು ಅನಲಾಗ್ ಫಿಲ್ಟರ್ ಇರುತ್ತೆ, ಅದನ್ನು ಡಿಜಿಟಲ್ ಫಿಲ್ಟರ್ಗೆ ಯಾವ ರೀತಿ ಟ್ರಾನ್ಸ್ಫಾರ್ಮೇಷನ್ ಮಾಡ್ತೀವಿ. ಓಕೆ, is there any doubt in this? You can after this you can go once again and check it how I wrote this. Okay, go back to your signals and systems, just refer the z transform of this, or else you can solve it for the z transform and obtain this standard form. One thing you need to remember, these standard formulas. Okay, I have a method 2 for this. So this is method 1, whatever we discussed. So this is method 1. Okay, in the afternoon class I will show you the another method also to solve how to approach this, both the methods, whichever you feel comfortable, you adapt that particular method. Okay, in the next in the afternoon class around 3 p.m. from 3 to 4, I'll start with method 2 and one more examples probably from this particular topic, and then in the next class I'll go with the second concept of the digital IIR filter. So that is a numerical method. Is this clear, guys?